It's Don here from the board. Thanks for coming along and checking out this video. So today we're doing a bit of a repair video. Uh, on Discord from the local community, there was a person who had a keyboard that was acting up a bit. I'm not going to flash up the actual uh, key tester, but essentially they had a really weird pattern and they weren't quite sure what was going on. So them being local to me here in Sydney, I was able to arrange to help them out by meeting up with them, getting the keyboard off them, and running some diagnoses. So the keyboard itself is the Mechlovin Studios Hex 6C. I'd never actually seen one of these before, but I was pretty confident that it being a Mechlovin board, it would have had a pretty standard kind of matrix. I just needed to actually get access to what that matrix looked like. So uh, here's the actual PCB itself. It's a through-hole soldered board. It is a few years old now. They've got some, I'm not even sure what these switches are anymore because I've kind of been off the space with the switch game for a very long time now. But it's a southpaw, which is a left-hand numpad with a rotary encoder on it. The rest of the actual keyboard is in a case down below, but I've taken this out specifically because obviously I don't need the rest of it. So the F1 Q keys were not working, and the left GUI key was not working, as well as the F key and the J key. So they were very unusual in their isolation. Of course, I have the experience in understanding the matrix for keyboard layouts and things like that, if there's schematics available to be able to test them, but I can also do simple tests just with a multimeter. So let's just go through what I did very quickly and checked. But essentially, I was able to find on the internet this particular web page. So this one here by Adam WS. Thank you very much, Adam WS, whoever you are, because this page was amazing. I've actually bookmarked it now, but I can throw in just hex and find the Mechlovin Hex 6C, which is what this keyboard is, and it allowed me to actually click on it to not only confirm that it's a pretty standard matrix, but also the PCB render told me exactly where those columns ran because I can figure it out from the fact that that's going to be the escape key F1 1QA. And then this oddity here, which I'll show you in a moment, this one here, switch 87, is actually called nubs. And then of course down into the left GUI. And so I took a copy of this, threw it into Paint, and then I labeled it, flipped it around so I knew which way it was facing on the back of the PCB. Made a huge difference, very easy to work with. So this page has captured like a whole bunch of stuff of all the keyboards that are available from via layouts, which is just amazing. So thank you very much, Adam WS. So what I was able to do with the multimeter, if we just go to first we'll go with diode mode first. So in diode mode, I wanted to test that the diodes were working because obviously if the diodes aren't, you need to replace the diodes. Pretty straightforward. So with F1, tiny little SMD diodes, I can put the probe against top and bottom of them, and as you can see, the value is there, so the diode's working. I can quickly do that with number one, it's working. I can do that with the Q, it's working, and I can do that with the GUI. It's working, right? With F, diode is good, and with J, diode is good. So eliminates that being a diode problem. Now we can stay in diode mode because we can check that the row pin is connected electrically to the other side of the diode. So what that means is we would test from the row pin to the bottom of the diode. So we can do that, and we've got a value. So we know that the electrical path through the switch, through the diode is good. Now we want to check if the diode to the rest of the row is good. We can go from the row pin to the diode next door on the on the common rail, which is the row. And if I can get it right, you can see on the next key, on the next key, on the next key. So, and I tested that for diodes across all of these, which means that the row functionality against the matrix is not the problem. So now we can switch to continuity mode, resistance mode. Now this is a cheap one, so it doesn't beep, which would be handy. But when there's continuity, it's low resistance, which is what we're after. Now I can put it across the 2 pins of the switch. There's no continuity, but then if I actually press the switch and put them to it, you will see the value drops down, therefore the switch has connected and it works. So you can test that the switch itself is good and all switches are fine. So now in the column, based upon the schematic, so what I'm talking about now is when you do these checks, uh, with either this rendered view or the schematic view, it doesn't really matter. They're exactly the same, just presented slightly differently. You will have this red line going from a column pin to a column pin to a column pin. The difference here is that schematically, these show the electrical interconnectivity, but the PCB render tells you exactly where the traces run. And that's really helpful. The reason why that's helpful is because you can actually run these in parallel, but they still are electrically the same. So knowing how it was run just allows it to give you a greater degree of confidence that something unusual is going on if you discover that it's not matching your expectations. So what we can do is we can have a look at, say, first of all, one that is actually working correctly. So the escape, which is this one here, down to the grave, I can put them on the 2 column rows and you can see that there is a value moving, right? So the resistance is coming down. Escape to tab, escape to caps, in theory. Oh, caps is flipped, my bad. Escape to shift and escape to control. So there is a electrical continuity, there is a connection between that entire column. Now, matching that against the schematic and the PCB render, the F1 column should be the same. F1 to 1, to Q, to A, to nubs, to GUI. So this is where things got a little bit weird because A is the only one that works, but 1 to F1 is connected, to Q is connected, Q to 1 of course is connected, it has to inherently. A to Q is not connected, to 1 is not connected, to F1 is not connected. So there's something a little bit strange going on. So A to nubs is not connected, to GUI is not connected. But if we go to nubs, nubs and Q is, nubs to 1 is, nubs to F1 is, and nubs to GUI is. So there's something strange really going on. And essentially what it comes down to is, if we have a look at this a little bit closer, the A key, if you look at the column pin, which is on the right-hand side, just above where it's printed A, that is the physical trace that is coming out on the PCB. That diagonally up and to the left line, right next to the A, okay, that is the physical trace. But the trace between A to Q, A to nubs, which is this one underneath it, okay, in the middle of the screen-ish, nubs, and A to GUI, those are on the other side of the PCB or inside a layer of this PCB. You can't see them. But the pad, the soldering must have been damaged wherever that trace is, because the A key itself worked. So this side where the trace runs along here, let's just get something to act as a pointer. Okay, so where is it? Yeah, so this trace here that runs down, this one here to that pad is actually still working. But whatever it is that is connecting it between A to Q, A to nubs is broken for both, which means the pad is probably burnt or lifted. So that was an interesting discovery. And then by doing exactly the same check, we can discover that F to R and F to C is not electrically connected, but C to R is, to 4 is, to F4 is. So the pad on the column pin on F is damaged, and similarly J to U, nothing, J to 7, nothing, J to F7, nothing, J to N, nothing, but N to U, N to 7, and N to F7, something. So it should be a pretty straightforward fix for this now that we understand. We just have to bridge the circuit, the trace, for J to one of its adjacent column pins, for F to one of its adjacent column pins, and for A to one of their adjacent column pins. So that's what we're going to do. Let's just put that away for now. Just move that to the side. I've got some wires here. I've got 4. Now, you might say, these are really long. They're just some USB power wires from an old micro USB that was really badly damaged. It was very old. The plastic was coming off it. It was all cracking and stuff. I managed to dig it out of a box somewhere. I think it was the original cable for my wife's Kindle. Anyway, I've stripped out a section and I'm going to bridge it. I'm going to wire jump from the pin to the next one. Now you might say, wow, that's really long. You should cut it down. It's going to look really ugly. Well, one, yes, I know. But two, it's easier to work with when it's longer and it actually puts less stress on the joint. And if you need to do a further repair at a later date for whatever reason, you've got enough length that you can go to any portion of the board. So if I needed to go from 7 to the J for whatever reason, then I've got plenty, right? By having this extra slack in it, if it was really at a weird angle and really tight, the wire wants to just do its own thing. So people use speaker wire because it's really thin and flimsy, but because this is coated and it does have kind of a memory to it, it's better to just have a bit of extra length. There's no harm to it. So we're going to go J to, I could go J to F7 if I really wanted to, but I'd probably just go, J to U, and then we'll go, F to R, and then we'll go A to nubs because nubs actually has a fresh unsoldered point, right? So we're going to use my TS80. Yep, it's the TS80 with the round tip there. Just excuse me for a moment. And yeah, so we'll turn that on, heat it up, tin the ends of these wires, and then put it together, and then we'll plug it back in. Hopefully everything's going to be all good, and we'll be able to test it out. So let us begin by heating up. So I normally run about 300 to 320 Celsius on my soldering irons for jobs like this. I'm using just a, what is it, 60, yep, it's a 60-40 tin lead. So, I don't have to use lead free. if I'm just doing things as a hobbyist, and I'm just using good old Sonotech, Duratech Sonar stuff. 1 kilo roll has lasted me many, many years. So there we go. Just cleaning off the old solder. You can see it's running at 320. Just letting it sort of get stable. Pull a bit of wire out. There we go. Feed that in. I really should get my fume hood ventilator thing out of the shed, but I haven't really been doing very much soldering for a while now, so that's why I haven't, because I just don't have the space inside the house. So I'm just tinning the ends of the wire. If you're not familiar with doing a lot of soldering, it's always good practice to tin the ends of the wire so that it has a coating on it. It has an affinity to the solder already, and that way it just is a little bit easier when you come to make those joints. Okay, so that one essentially will have a very fine coat of solder applied to it. Let's go with the white so we can see the white easily. Pair of automatic wire strippers is very handy in this kind of space, which is what I did use. Well worth the, I don't know, $30 or whatever it was when I got them at the time. Okay, tin that side. Even though these wires are really small, they still retain quite a bit of heat, so even if you do tin them, just got to be very careful not to touch them straight away, because you will burn yourself. They don't have a lot of mass, but they do get very hot very easily. So safety is always important. If I was doing a lot of soldering on the whole board, for example, I probably would go and dig out my extractor, but I'm just really going to be doing a very small amount of touch-up joints here. So we're not going to be too bothered. Alright, come on, just a little bit more. Okay, alright, so I've got my J, F, and A wires ready. And now let's start with winding this back up first, so I don't have a massive line of solder hanging around. So let's use tweezers so I've got a bit of control. We can go upwards. So I'm going to go that way, I reckon. Let's bend that actually around. Something like that should be okay. Just don't want it to contact, of course, the other side of the switch in. Should not be trying to do this while I've got a running nose. Of all the times to have a runny nose. Alright, let's get back to this. Okay, so we will actually put that there. We probably want to just refresh the solder on this joint, by the way. Okay, we just got a bit of extra solder onto that. There you go. Easy as. Look at that. Nice. Strong. I probably don't want that radius. Let's go up to, let's go up to the F7. Let's just put a little bit of that bend in there as well. And we will refresh the F7. Okay. All right. So F7 is now attached. And let's just quickly check. Let's say N to J is good, and then J to U, J to 7, and of course J to F7 is good. Okay, so the J is electrically good now. Chuck that on the chair behind me. All right, let's go with the white. What happened to the green one? Did I knock it off the table? Is it my lap? Strange. All right, well, let's just use the white one. And we want to find the F, which is this one here. The reflection makes it a little bit challenging, but we'll just put a little bit of bend on that. And then let's refresh the solder as well on the F column. There we go. Don't know if I really need tweezers. Let's just put them aside. Thought I might, but it's okay. ASDF and all right, F is on, and let's just go up to the F4 to be consistent. Let's refresh that, and in it goes. Let's check. And we can go from the F to F to C, F to R, F to 4, F to F4. Excellent. And now the mystery of the green wire. Where did I put the green wire? I've seemed to have misplaced it. Good job. Oh, there it is. It is on the floor. It did fall. Alright, so there is the green wire. And then with this one, like we said, we're going to actually take it down to nubs because it is a fresh pad. This one's a bit of a tricky one in that, well, while the pad's busted on that, we can be a little bit freer, but because the A is actually where the trace comes to, we need to be probably a little bit more careful. So yeah, I think we're going to go this way and take the A, and we're going to come this way onto the nubs. All right, so let us first of all caught up on the bottom of the pin there. Okay, So let's do, we're going to just tin the column on nubs. Right, and then we'll do the pad on A. Okay, so we want it to kind of go like that. Let's give that a little bit of a bend there. Get out of the way. We'll stay away from the trace side. So that's on. And then that's on. Okay, so that's nice and firm. And then let's see. we will see if the magic worked. So we're going to go from A to nubs, A to GUI, A to Q, A to 1, A to F1. Now, of course, the risk is if we actually damage the trace connection to A, but we won't know till we put it back together. So what I'm going to do now is I'm going to put the multimeter away. I'm going to unplug the iron, but while it's hot, I need to feed some fresh solder onto the tip just to cover the tip and protect it from any unnecessary oxygen weathering. There we go. So it's going to smoke for a bit. Takes a little bit for it to cool down for that solder to firm up. It's got to get under about 200 something odd degrees. Takes a little bit to hold it. So yeah. Now I do have a video on doing the multimeter testing. I do have a video on some examples of wire jumping or bridging. You know, that this is basically what the solution fix is for. It's a pretty kind of straightforward process once you actually understand how to read your schematics and PCB layouts and things like that. For community created boards, they're very easy to do. For OEM boards, it's potentially a lot harder. So there are boards out there that I've had a look at that I've tried to do fixes for, but their matrix is not straightforward. I have actually mapped out I think it was a Thermaltake board, and it was all over the place. It was very, very hard to actually make rhyme or reason with it, which essentially made it practically impossible to fix it because I just could not figure out where that column was meant to be because there was no consistency in how it was actually put together. And that can make things really, really challenging without somehow getting access to OEM level equipment, not equipment, OEM level data to be able to actually know where it's meant to go in its switch matrix. All right, so let's just put some of this stuff away because I don't want sharp, pointy things that are going to scratch. I think it's the E-white coating on this keyboard. We'll see it in a moment because then obviously the owner of the keyboard is probably going to not appreciate that very much. So it came to me when I met up with them in this really nice hex keyboard case. It's got a carry handle. It's got dual zips on it. The inside of the case has a top pocket for bits and pieces, and it's got straps and foam. And so there is the E-white of the case. So I'm going to take out the top part of the case because we don't need that because we want to get to the bottom. There's a JST connector involved here. So we will need to plug that JST connector into there so that the daughterboard USB will work. And then we can plug it in, throw switch tester on, and then we can see if the magic works. So there's the JST connector, and it needs to go onto that. So let's put that on. Let us make sure that we have the correct orientation for that. The pins are on, I believe, well, the fathead orientation should be that way. The wider is on the top. So I believe it should be this way. Of course, never force things. Yep, nice and smooth. Connector in, and then into its little space, and then the gaskets. So this is it's a gasketed board, like that. In theory, that should be good. Now, it is a USB-C, so let us find an appropriate cable. I'm going to give some space for this. Here is my extender. Boop. And we have connection. So the LED has lit up now. And then let's open up switch header. Okay, I've got switch header open now. There is my right monitor. Okay, let's just shrink that so we can see what's going on. So I'm going to select the switch header and escape. F1 works, 1 works, Q, A, Z, Win, which is the left GUI, works. Okay, and then we have AS, D, F works, GH, J. Uh-oh. Did I miss G? Was G one of the keys not working? T, G, B, V, Y, R. Okay, that is a little concerning. I'm going to turn off the monitor and I'm going to hop into Discord, and I will quickly check if G was actually a non-working key, because there was actually screenshots of the keys that weren't working, and I just wonder why. Okay, I don't know what is going on. Discord keeps wanting to open things in a browser. Weird. Discord, what on earth are you doing to me? Alright, I'm in the right channel now. Let's have a look at their VR key testing. The F and J were distinctly not working. Why is the G no longer working? I haven't done anything to the G. Oh boy, oh boy, oh boy. That is not cool. Have I somehow magically fixed the keys that weren't working and then another one has failed? All right. This is keyboard repair life. So I'm going to unplug that, and then this is crazy. And then we will carefully take the connector out, and then G, of course, is right next to it. Hang on. I just want to show that I'm not actually crazy. So I'm just going to open the image and then close Discord. Right, there we go. This was what was not working. So F1, Q, left UI, F, and J. G was working. Okay, so G had no problems previously, and now it does not seem to be functional. So out comes the multimeter. Quickly onto diode mode. Let's test, because if it's the same problem, that's an easy fix, but got to make sure that it is. So G diode is okay. G diode to the row is okay. Columns. So G pin to V is working. G column, the G column is okay. So is it that the switch is bad? Like, but G to the pin is okay. Electrically speaking, all right, I need to depress the actual G switch, and then let's do a bit of acrobatics. So that's one pin. G is okay. So why is G not registering? Is it because G is mapped in a weird way? I am so confused right now on why it's not turning up on switch hitter, but there's not much I can do about that. So I'm going to plug this back in, and I'm still going to send it home on its merry way, because that's as much as I'm going to be able to do for it right now. And electrically speaking, the matrix says it is fine. I don't know why it was misbehaving. Okay, so we're just gonna gently pop that back on to its relative gasket positions and try it again. USB in, lights are on, right hand monitor, switch hitter, clear it. I mean, it's much the same. It should just be G is G, right? F, G is working. Did it just have a bad connection? Okay. All right. Excellent. Okay. That LED is really bright. Boop, boop, boop. Space. Everything else seems to be... Oh, it's Southpaw. Confused the heck out of me just then. Enter and control up the top here. Fun. There is no numlock. There is no numlock. Backspace. Okay, interesting. And then the encoder is doing something, but I don't know what it's doing. Okay. All right. So everything works. There's just no mapped numlock. F1 works. 1 works. Q works. F and J. And that weird G. Everything is all good. Whew. I thought that I was going to have more problems, but no. All right, so let's just unplug that. That is in. I don't feel like it's pinching anything because it's not giving any rise to any problems. The gaskets are only top to bottom. And I can see that that one's in there, and this board is heavy, by the way. It is. It has got some serious heft, and the top gasket is in, so I can take out the top of the case. It's quite nice, and carefully. Has it got gaskets on there? No, it doesn't. Okay. I just need to make sure that it lines up correctly. And that is the Mechlovin Hex 6C. Now, it is a beast of a board. It has got so much mass to it. That's the back of it, the Hex logo. It's got some bump-ons. The profile is quite a high angle, I feel. And it's got a bunch of screws on the back here. So I'm just going to drop in the 4 that were in it when it came to me, and then the owner of it can actually replace the rest of them as they like. It is actually hex bolts on these. I think they're M2 bolts. There's a whole bunch of them there. I don't actually have a screwdriver with a bit long enough to get into the deep ones, so I had to use my Allen key set here, and the smallest one is a 2, so it's a 2mm M2s on these. So they just had the 4 corner ones in it for the purposes of transporting it over to me, which, yeah, is all well and good. Let's just get one. I'm not actually sure what the mini paddle pop stick is for, but I'm assuming it's something to do with the gaskets. I mean, it's the only thing I can think of on why you would have them, have it, whatever that is there for. But yeah, the community knows how to get creative, shall I say. All right, so this corner, because obviously the encoder at the moment is got all the weight on it, so let's just turn it in the opposite direction until I can feel it seat itself. No cross-threading here. And let's get that in. I can't really do a proper review of these because there's no keycaps on this. I don't want to put some other keycaps on it that aren't, you know, the keycaps of interest or desire, because potentially if it, you know, damages or wears the switch, then I don't want to do that. Doing this with these Allen keys is such a chore compared to having a nice wrench or something, or a screwdriver with a 2mm hex bit on it, but that is how it goes. Here seated. There we go. I can feel that click. Alright, and then the last one. Here's the click. And snug. Alright, it's all closed up. That one probably could do with another little bit of a turn. snugged up. All right, so there it is, the Mechlovin Hex 6C. Wow, that really, it will give you a workout, but it ain't going anywhere, that's for sure. Acrylic plate, PCB has a little bit of flex on it. It's obviously hard to give you a sound sample without keycaps on it, but the gasket and the plate has a little bit of flex. Case obviously does not flex, will not flex. All right, that's it. Wow, we've hit 45 minutes on this. I mean, I think that's a reasonable amount of time for checking through and putting this back together, fixing it up, making sure that it works. I'll get in touch with the owner of it later today back on Discord, and yeah, be good to see it go home and enjoy a long, long life, hopefully, until they decide to swap out the switches again. But at least the wires are there in place and they know where they need to go. All right, thank you very much for coming along and checking out this video. Hopefully you enjoyed having a look at the process, even though it was very quick, on how to diagnose some switches that aren't working and then doing a bridge activity, wire jumping activity. Thank you. If you like that kind of stuff, please hit the bell button, like button, subscribe button, the usual stuff, you know, us poor small content creators as we are. And of course, until next time, happy clacking.